I'm Bill Steele with the Bureau of Reclamation. I'm the area manager in Southern California. Puts me under the Lower Colorado River District region out of Boulder City, Nevada. And my co-facilitator today is Jeff Mosher, whose office is at NWRI, National Water Research Institute, and it's housed in Orange County. He's co-located with the Orange County Water District. And what we want to talk to you a little bit about today is quickly give you a briefing on some things about, so we can kind of set some ground on where everything's at. A couple of things that were said in the main section that I think both of us agree need to be corrected. When you talk about portable reuse, there is portable reuse in California. There is no direct potable reuse. There's only indirect at the current time. There's projects that may go to direct, but they have not been finalized because the state of California has not finished its regulations yet to do direct potable reuse. So that's just kind of, I'm not trying to correct it as much as just say we all want it to happen, but it hasn't gotten there yet. So that's an important thing. So we're going to go ahead and just kind of cover some real quick things to kind of set the ground rules, as well as talk a little bit as an introduction, because what we want to do is hear from you all during this session. We want to have the input that we can add to what was said at the early session this morning. So the first thing, we've set some ground rules for the session. Everyone's encouraged to provide input to a question if you'd like to and if you have anything. We are not here to discuss or oppose suggested ideas. We do not want people to we do want people to express concerns on proposed technologies if they exist, but not because maybe you don't like the technology, but if there's a real concern, we do want you to say that. Limit comments to proposed solution. Keep responses short. Our desire is solicit as many ideas as possible from everybody in attendance. Now I'm going to go through real quick, and just because we have 26 projects the Bureau of Reclamation is involved in Southern California. Nationwide we have 53. And everything that I'm going to talk about here, at least one of the projects that we have running in Southern California provides water for each of these uses. One of the comments I did want to add too, which is important, in Eastern Municipal, they do have 100% reused water for all agriculture. And they produce it for I think they sell for about $330 an acre foot, which considering the cost of net water, that's pretty darn cheap. So anyway, water is used for urban, industrial, ag irrigation. We have a number of environmental projects in Southern California as well as in the northern part of the state. Potable reuse through groundwater recharge, surface water augmentation, and eventually direct potable reuse, which is being proposed for 2 different projects. Urban applications that we have all through Southern California and other parts of California. Irrigation, of course, public spaces, outdoor landscape or residents. For example, Irvine Ranch does dual plumbing. They have outside reuse for landscape, and they have inside water, potable, fresh water for the inside of the houses. They also dual plumb some commercial and industrial buildings in the area, as well as landscapes, golf courses, ornamental landscapes. The commercial buildings, there's the toilet, urinal flushings, and dust control. One of the things that I think was pretty important that you heard about the urinals and the toilets, before I got here, I've been down there 13 years, but before that, back in the 1990s, the federal government put in a program to transfer out 2 million toilets in the LA area, and the Bureau was given the task to work with the water districts in LA and other water districts in that area to exchange toilets to put in the 1.6 low flush. So there was a tremendous effort in the mid-90s. There has not been an effort like that with the federal government since the mid-90s. It's also used for dust control, fire protection, and then, of course, both the potable, indirect, and direct. Industrial uses primarily are cooling water, once-through cooling, recirculating, boiler makeup water, and industrial process water. We do have one particular district, which is West Basin. If you do get a chance to go to Southern California, go to El Segundo and go to their plant. They make 5 different types of water for 5 different types of industrial as well as landscape uses. And then, of course, it's also used for energy production. These groundwater recharge things are taking place right now. One of the things down in the South Coast area is everybody, like in Orange County, has groundwater rights, but the problem with Orange County water is they have to help keep the barrier so the salt water doesn't come in from the ocean, as well as make sure through the indirect use that the water's in the ground when the people pump their water. So saltwater intrusion barriers are a big thing in Southern California, provide further treatment for soil, aquifer treatment, augment potable aquifers, used for aquifer storage and recovery, and then the benefits, of course, storage and control or prevent of groundwater subsidence. Then the potable reuse is augmentation of groundwater and surface with recycled water, and the use of an environmental buffer, and then the direct potable reuse through the use of advanced treatment. We hope that eventually we'll be able to get it into the system just like was mentioned during the first session. Now, I think you want to take it over here? Okay, we have ocean desal on some of it down there. Of course, most of it's in pilots. The main plant that's coming online is the Poseidon plant at Carlsbad. That plant's going to produce, I believe, 50,000 acre feet. And it's currently in construction, and I believe it's supposed to go online some toward the end of 2016. Open ocean intakes or sub-intakes, we're trying to help. One of the things the Bureau of Reclamation was asked to do by the National Academy of Science and the federal government is to help spend our research toward keeping the cost of production down through the membrane development, as well as review the environmental problems and try to minimize environmental problems through reuse, the intakes, and other opportunities like that. The big issue then is brine return to the ocean. And then on the brackish, we are involved in pretreatment and reverse osmosis. And the biggest problem in the Inland Empire, which is where most of our brackish plants are at, is you've got a brine concentrate that you have to get rid of. One of the districts is going to go to pelletizing the brine, which means they make a certain aggregate size of it and they sell it to either asphalt or concrete process, and it's used as the aggregate to make concrete or asphalt. The only way you can do that is you have to have pretty close co-location. I believe the location of the plant they sell it to, plus they get money for it, is within a mile. Because one of the big problems on brine concentrate management in the Inland Empire, if you have to carry it very far, you can't pay for the cost. Okay, and then the final one, let me just go over this, and I'm going to turn this over. We are doing a study with LA County on stormwater augmentation, and between work we had done previously about 5 to 10 years ago, plus what we're doing on a $2.5 million study with LA, 2 to 250,000 acre feet of water on an average year is potentially available from the runoffs on the Angeles Mountains, and we're trying to work with them to help look at recharge areas for that water, and I just want to add that to this slide.
Thanks, Bill. I'm glad you did, because I threw this in this morning. It was a bit of a curveball. But one of the things we think about in working with agencies is that we want them to we want to encourage them to use a lot of their local supplies, and that's why we're talking about water reuse, desalination, brackish water desalination, taking advantage of impaired groundwater, for example, and stormwater is another big one. I know it's not specifically on the agenda, but there's a lot of technologies out there related to stormwater. If they do come up, I think that would be fine because, again, I think this fits in with what we're thinking about in terms of the conversation. Okay, so what I wanted to cover is just what our current technologies are. This is not meant to be comprehensive, just give you a flavor of what we're working with now. I'm not necessarily an expert with all these things. I tend to work with them generally with agencies, but I want to run through them just so we're all on the same page. So from a wastewater point of view, our current technologies are activated sludge and trickling filters, which is a biological treatment, very standard, you see them a lot. A technology that's coming down the pike that we're seeing more is membrane bioreactors, involves the use of a membrane. The effluent from this tends to be a little higher quality, and it's very good for reuse. There's disinfection at all these facilities. Commonly it's chlorine, but we're seeing a lot more UV disinfection used. We don't create byproducts. There's a little more flexibility in terms of using UV. So I put nitrification, denitrification up here. This is the ability to take nitrogen out of the wastewater. If you're using your water for irrigation of plants, you wouldn't necessarily want to do this. You want to keep the nutrients in it, but there's some advantage to further advanced treatments if you do nitrify, denitrify the water. So another area that I kind of threw in here because I thought it might come up, and I think it's going to be a big part of our future, is resource recovery. So when you think of wastewater treatment plants, there's three things in the water that potentially is value. The water, so we do reuse, the nutrients, be able to pull those out, particularly phosphorus, and energy in terms of the organic matter. So a lot of the wastewater research that's going on today is involved around turning these into more resource recovery rather than a wastewater effluent discharge facility. So for non-potable, typically we have filtration and disinfection. That's very common for use in irrigation of ag and other non-potable uses. So there are some things that are coming down the pike that are really innovative in the wastewater side. So one of my member agencies, the Orange County Sanitation District, has a research project looking at a technology called OpenCell, which is meant to open up some of the microbiological cells that are there. The reason we want to do that, you can increase the biogas production, so you can get more energy out of it, makes that process more efficient, and it reduces the biosolids. So the amount of organic matter that they have to land apply later is reduced as a process. So this stuff, I'm telling you, is exciting. We don't have a lot of these things in place. One question was, what can we learn from overseas? You have some places, Netherlands, other places that may be more advanced on these types of things. We can take advantage of that. I just want to throw this up here because, again, Orange County Sanitation District, they have a hydrogen production through a microbial fuel cell. So they treat the water through this advanced technology to create hydrogen that can be used for gas and other uses. So I just want to throw those out there from a wastewater point of view. There's a lot of exciting stuff that's going on. The nutrient recovery is another one. There's a lot of technologies that you see out there that separates, again, the phosphorus and nitrogen that can be used in the market. So on potable reuse, Bill mentioned this, on groundwater spreading, typically you can use that without any sort of additional treatments. You can take tertiary water, and then you use the aquifer or the soil or the ground for treatment. And this is natural filtration. It's very well documented. It's very robust. So you get a lot of treatment just by the water percolating through the ground. For projects that put water in a surface water reservoir, or if we want to inject the water directly in the aquifer, the state has termed this full advanced treatment, and it involves microfiltration, reverse osmosis, and advanced oxidation. Oh, I forgot one thing. Okay, so RO concentrate. So we run the RO on this water. We end up having this concentrate. Some people call it a brine. Typically, a brine is going to have a very high saline content. The salinity in this may be 6,000 parts per million. So I use the term concentrate. Some people use reject, but it has to be managed. If you're on the coast, you can discharge this to a wastewater outfall into the ocean, common practice, and you could argue that the ocean is a bit of a salt sink. We also have brine lines that can take the RO concentrate to the ocean, but if you're in an inland area and you need to treat that, those technologies tend to be very energy intensive and expensive, and so that results in two things: trying to incorporate technologies other than reverse osmosis and trying to come up with technologies that aren't as intensive to be able to treat the concentrate to, one, get more water out of it, but also to treat it for discharge. So I'm going too fast. This is the full advanced treatment. I just want to throw this up because a lot of communities, a lot of water districts that are looking at potable reuse are going towards, I'm not going to call it, the term is probably, the best term is standard. It's sort of the industry standard for how we're treating potable reuse. It is not the only treatment train that can be used, but it's one that we're seeing most common. So it involves taking secondary effluent from a wastewater treatment plant, running that through a microfiltration, which removes particulates, but also pathogens like protozoa. That's also a pre-treatment for the reverse osmosis. That's the workhorse of the process. That can take out a lot of the trace organics that we hear about a lot, the compounds of emergency concern. It also takes out salinity. So it has a lot of benefits being able to RO water. So not everything is addressed through RO. So the regulators have a process that they like to employ here called advanced oxidation. So this breaks up some of the compounds that get through after RO. Okay, so I threw this up here just going to give you an idea that there's a almost a plethora of technology that can be used for treating water. And we can treat water to any quality we want. It's just a matter of money and energy. So this technology, this slide was put together by a firm looking at what are the technologies for addressing concentrate that can be used for other purposes. But the RO is osmotic membrane processes. We're seeing advances there. We're seeing hybrids of those. So there's still advances that we can will have on this side of things. It also involves forward osmosis, which will use a lot less energy than RO. It might be more useful on a concentrate at this point. It's not ready for municipal treatment though. And then there's others that are electrically driven processes. And then there's also other innovative ones that involved in recovery of salts, innovative membranes, processes that I call hybrids that involve multiple different technologies. And then there are some biological systems. Aquaporin is one that's a protein that occurs in nature that you can use to filter water. So there's a lot of work going on there in terms of research. One thing I want to mention is for desalination, there's also a lot of options that are being currently looked at. We talked about forward osmosis, but membrane distillation, which is a hybrid system between using membranes and distilling it. These hybrids getting a lot of attention, and looking at the brines, using the brines in a way that you can produce energy. So there's a lot of innovation. And one thing I want to mention is that the industry is out there getting together and talking about this. And this is an event that's in August that we're involved in with some folks from Australia and from Saudi Arabia. And it's bringing in a lot of people from around the world to talk about these innovative technologies. So, Bill, maybe I can turn it back over to you, but these are the questions that we're going to want to go through for the interactive portion. So I'll give it to you. You can go through these for us.
Yeah, we'll both do it. Sure. We're going to go through the questions they gave us first, and then if some other people have something in the end, we'll add them. We do have a note taker, and so we want to stay on each question as long as we need to, so that we can capture the notes, because one of the things out of this session is there'll be some information sent on to the state, the governor's office, about things that came out of this meeting other than just what we heard this morning. So our first question is, where do we stand, or the advanced technologies stand? And we kind of had an update from Jeff. Does anybody have anything else about technologies that we may have slipped on that we need to be sure the state is aware of? Yes. And would you stand and maybe just say your name real quick and then the technology you want to talk about?
Matt Gray here on behalf of Pacific Airwell. The technology is the atmospheric water generation, which actually pulls microscopic droplets of moisture out of the air, condenses it, cools it, and it's drinkable water, which is then treated. And it just occurred to me, and it had not before, that much like a refrigerator removes moisture from the contents of the food inside, these devices could actually pull out the water and leave the impurities behind. So from the, whatever you want to call it, if not brine, then reject. That might be a pairing up of existing technologies which would better serve the desal community, preventing the need to send the waste over the groundways or back into the ocean.
And what's the name of the technology?
It's atmospheric water generation.
Okay.
And Pacific Airwell.
So I'm glad you brought that up. So one of the things I did not mention is how these technologies are operated. Okay, one, they're advanced, so they take advanced treatment. But because the water is of such a, especially the concentrate, such of a challenging quality, there's a lot of issues associated with scaling and fouling. And so one of the things that we'd have to consider with these types of technologies is how do they perform in that type of environment. Oh, Peter, there's a microphone right there.
In similar vein to the previous comment, there's actually a Dutch technology. If you give me long enough, I remember the company that makes it, that uses a windmill basically to drive a compressor that compresses air. That air is then allowed to expand, and as it expands, it catches the condensation. So given the prevalence of wind power in California, the idea of wind-generated water has a certain synergy. The only drawback, I think, might be that the air in California is pretty dry. So I'm not sure how much water there is to capture out of it in the first place, but it might certainly be worth investigating from a feasibility
And
point of
there's
view.
a specific name for the technology?
I'll have to come back to you on that. But it's,
Okay.
yeah.
We'll provide it to the note
Okay.
taker. Thank you. Anybody else? Over here, right here. What? Okay. What?
Yeah, one of them I think you might add to your list would be cloud seeding or precipitation enhancement. It might be very practical cost-wise because a project has been proposed above Shasta Dam that where we've already got a half-empty aquifer. And this could provide a lot of cold water as well as additional yield. PG&E thought they might get 200,000 acre-feet per year out of it once it had been in process for some time.
Okay.
So,
We have your name too?
oh, Maury Roos.
Okay. And the cloud seeding has been done in other areas, but it is being redone by some other states in the West right now. Yes. And on towards the Rocky Mountains. One second. Back here a minute. Okay.
Hi there, Steve Green with Xylem. So we have a technology, we've named it Auxilia. So it's an ozone followed by a biologically active filter. Some of the disadvantages that were mentioned about RO, this is a good technology to avoid some of those. We've got a pilot down in San Diego looking at a direct potable reuse or indirect potable reuse. It's been active for a couple of years now. And we've got a booth out here, so happy to talk to anybody about that.
I'm glad you brought that up. So we didn't have a lot of time here, so we didn't go into some of the alternative technologies, but one that is ready for prime time is ozone, biologically activated carbon. We could do that today. Because it hasn't been implemented much, we're going to see the demonstrations like down in San Diego and other places, and it doesn't have the brine, and it does a very good job of being able to remove the trace organic chemicals. So it's definitely a viable option, I think, moving forward for California, especially for some of the spreading projects.
Okay. And one of the key things too, because we're trying to find things to help California fairly quickly, but at the same time we need to be looking for the future. So be sure to let us know if it's still in the development stage as opposed to actually close to being actually installed to be used. Yes, real quick.
Yeah, sorry, that company that makes it.
EOLE. Did we get that? Okay. Thank you. Let's go down here. And then the next one after that will be over here.
It's David Rumler. At Stanford, we have a real-time MBR system and monitoring, real-time monitoring. And the monitoring is contaminants, all kinds of contaminants, nutrients, and pathogens. The pathogens uses microfluidics. And I didn't know I think monitoring is an important piece of this thing, and I didn't see anybody talking about monitoring today.
Right. So that's an excellent comment. And the point of all these treatments is to control for pathogens and chemicals, right?
Right.
And because we're focusing on the water supply, we sort of focused on what the variety is. But yes, there are innovative monitoring technologies out there that potentially are real-time, online. They're going to give us a lot of information on the performance of these technologies. And frankly, the regulators like seeing that information because it gives them confidence that the water that's being produced is appropriate public health. So yeah, monitoring is an area that if there were specific suggestions on that, I think we would take them here.
Okay. And there's another technology that I'm also working with. It's in Colorado, but it's real-time treatment of phosphorus using a bioreactor. I don't know if that was on your list. I don't think so.
Okay.
I can give that to you.
Yeah. Okay, comment over here.
I'm Bill Carpenter with EnviroCycle Global Partners, and what we do is decentralized sewer mining. Basically, we have a small advanced activated sludge system that takes the sewage and turns it into water that's able to be used for irrigation. Speaking of monitoring, it also does have real-time telemetry including turbidity sensing. So that was one of the issues that we were dealing with local regulators, which is something that is a barrier for a lot of technologies, is there's a disconnect between certain government agencies, whether it's state to state, state to local, or other jurisdictions, where there are competing interests. For example, in some situations, some regulators will say that if you can use a standard septic system, you must use a standard septic system as opposed to using advanced technology. So those are things that are a barrier. Right. But with this technology, we have about 54 systems installed in the Northern California foothills. And over the last 16 years, we've been able to successfully reclaim about 65 million gallons of water for irrigating turf, trees, and that sort of thing.
Okay. We have several districts, too, in Southern California that are looking at more decentralized systems as opposed to one big central system. Because one of the big problems you do have with recycled water, since we've actually got authorized 600,000 acre-feet of capacity, but we've only got online right now 380,000. Because a lot of times you can build a capacity, but if you don't have the distribution system in, you can't get it to where you use it. So that's always a big issue. Okay, back in the back there. And then we'll move up here next. Okay.
Hi, I'm Epa Rixey. I work for Lagunitas Brewing Company, and so I'll apologize if this has already been brought up because I walked in after the first couple comments. But I think a huge area for water reuse is industrial reuse. So we're a brewery. We generate water that's not that dirty, but has a lot of organic matter in it. So we have been working with Cambrian Innovation, a company out of Boston, to design a 3-phase treatment system that uses a anaerobic digestion system, burns the biogas, produces electricity, and then we can use that electricity to run an MBR and RO system. So we actually end up net producing energy, not consuming more energy than we would have otherwise, and taking our wastewater, reusing it on site, and then we'll be able to reduce our total water usage by about 40%. So nobody knows your own wastewater like the person producing it. So we're able to design a system really intelligently to reuse it.
So that's an excellent example, and it's not necessarily how we traditionally think of municipal reuse, but you're doing on site. That's great. We see a lot of other industries, whether it's laundries. I mean, there's a lot of variety. Vineyards are doing something similar in terms of treating their wastewater. So it's more of an on-site treatment type thing. It's not necessarily a municipal reuse, but it's more decentralized than a centralized system.
Did you have something to add? Do you have right there? Yeah, go ahead.
So yeah, I'm with EPA actually. I'm with the Cambrian Innovations, and to add to what EPA said, that we become a distributed utility on site to recover this waste. What he did not mention was around the energy production. We are producing about 15% of their energy demand for the facility. So it just makes sense for us to consider more and more with the breweries, wineries, dairies, etc.
Well, the interesting thing in the big casinos in Las Vegas, because our region also covers that, is almost all the big ones like Bellagio have their own recycling plants in the basement. That's where the water for the fountains comes from. Okay, anybody else? We're going to take a few more, and then we have to go to the next question. Yes, go ahead. The lady here. Get her the mic right behind you.
Right, thank you. Hi, Mariana Grossman from Sustainable Silicon Valley, and we're working with San Mateo and Santa Clara counties and all those cities and the companies there to do on-site water recycling the way San Francisco has enabled. But because there are so many different agencies, and it's a little bit more complicated to implement there. And so one of the things that I think will be important is being able to do monitoring remotely so that the Department of Health doesn't have to run around and test everything, and that the testing costs could go down. So I'd like to hear more about monitoring technology, especially for doing biological testing for blackwater systems. And then the other thing that I'm concerned about is I've heard that UV and chlorine interact in a detrimental way and can create harmful byproducts. So what are we doing when you do an RO and UV system and you have chlorine, what are we doing to prevent making those bad compounds?
Right. So that's one reason why you're seeing a lot of UV being employed, especially on the wastewater side, is to avoid the the production of disinfection byproducts. It is roads causes chloramine foam. Roads. Yeah. Yeah, but but I think the general point is that employing these technologies, you also have to consider some of these things like byproducts that might be formed, and that's part of the process. Rhodes, you have a follow-up to
that? In the potable use arena, the one thing we have a lot of the technologies, but what we don't have and prevents us from going forward are standards where the health department and the community, technology community as a whole have agreed on what each process does so that they can establish standards of what we need to accomplish, and they can agree that the process that we're implementing meets those standards.
Okay, I'm going to take 2 or 3 more on this one because of the time, but I don't think 2 is going to have much, and then we want to talk about 3, and then we can always go back to this one, but right there. Yeah. And then I'll take the one over here by the
Sharon Steiner with NSF International. So we're a company that just developed a standard for water reuse, and it was just implemented in the California State Plumbing Code 2 weeks ago. So it's a water reuse standard. We test the units and certify them kind of like UL for electrical components. We're more on the water side. The units are tested for 6 months, and they're tested for performance to make sure that they're actually killing the bacteria, the turbidity, the BOD, that's total suspended solids, and that they're actually producing a water reuse that's usable and that the regulators can use for their state codes.
Okay. Let me get one over here against the wall, right behind you. There you go. And then maybe one more, and then we're going to switch to the next question. Anybody else? Because you had to go in. Let me get one back there. Okay. Go ahead.
Hi, my name is Bill Worthen. I'm founding principal of Urban Fabric. We do sustainability consulting and communications. We are the sustainability consultant on 525 Golden Gate, the building that has the tidal flow wetland living machine in San Francisco, as well as 181 Fremont. It's an 800-foot mixed-use office tower to put an Aquacell gray water system in. The reason those technologies are there in San Francisco is because San Francisco has the regulatory environment to allow this technology to work. And even then, the perceptions and the realities of trying to get them permitted, the technology is there. We don't have the will to put them in, and we don't have the regulatory environment to allow them to happen in the urban environment, except in San Francisco. So thoughts on that?
So that's an excellent comment, and San Francisco is working on a project to take it nationally. So
right.
Other
Paula Keith and I talk a lot on that.
Right.
Yes,
right.
Yes. We speak. Yeah.
Last one back here on this question, the gentleman right there, and then we'll come back to this one. So keep it because it depends on time.
Yes, Michael Ross, Department of Water Resources, and back to the municipal side of things. There are some technologies that the department's looking at. They're pretty innovative, but they're to mix it with existing technologies. One is using waste heat for desalination. And then other is coupling solid waste disposal and the incineration of solid waste disposal in the landfills to actually generate electricity, but then using the waste heat from that electricity generation to desalinate water. So that would be 3 things. That would be solid waste disposal, energy production, and then not affecting the energy production, but then desalinating at the same time through waste heat. So there are some things that are going forward on that respect, okay?
Okay, thank you. Okay, we're going to move to the next question. Just one closeout. There is a system called Aquacell that GE has that currently Eastern Municipal is trying on to get recovery because of brine concentrate and stuff. It's on a brackish system in Paris, California, and they're looking to get it 98% recovery. We're monitoring it. The Bureau's in there giving it to see if it really produces. But so there are some things maybe coming on soon that might get recovery, particularly in brackish areas of 98% recovery. Okay, the second question, how can they be improved or scaled up? I don't know how much difference that's the first one, so we may not have a lot of comments. But does anybody have any comments on that? That's the lady right here.
Hold on, we need a microphone.
Oh, microphone, please. And that's all right. Get name and everything. We have a note taker.
All right. If there are technologies that are already working and you can prove it, why aren't we subsidizing them or providing accelerated depreciation, tax rebates, et cetera, to support their wide scale implementation. If this Cambrian Innovations is working in that one brewery, why isn't it working in 400 in California?
Okay. That's a good one. We'll put it in there, even though it may also be a way to move barriers too. Anybody else, any other comments? Right here. Okay. Go ahead.
To follow up, Jennifer West with Water Reuse California, just to follow up on that question, and I guess I've had this question, is there, I don't know, but if there are technologies that are working, that are proven, as we said, is there a kind of a clearinghouse or a place where somebody can go and find that information and whatever it is, stormwater, all these kind of innovative technologies? I think that would be really useful if it doesn't exist. I'm not 100% sure it doesn't. So.
Yes, over here.
That was exactly the point I was trying to make.
Here you go. Take the mic, please, because people on the webinars.
That was exactly the point I was trying to make on the panel when I was talking about best known methods. It's a method that's used by other industries, for example, the oil industry or the nuclear industry, to capture the best technological approach to a specific problem in a specific set of circumstances, and then to promote the use of that approach unless and until something better comes along. So a clearinghouse for that is absolutely essential because somebody has to declare them a best known method. Somebody used the term underwriter's lab earlier. I mean, what you need is an underwriter's lab for water management technologies and water management practices. And what you also then need is some kind of incentive structure to get people to use it. Often the incentive is they're going to save water or save energy and thereby save money, but not always. And that's the that was exactly the point I was trying to drive at.
So there is an Australian validation program that we're talking with Australians about. It actually has two purposes: one, to validate the technology, but also to tell you the information we need to get it permitted. Because often the regulators look at the new technology and they don't know what to require in terms of monitoring or operations. And so the Australians have this validation protocol that potentially could answer those types of questions.
Yeah, over here.
Can you hear me? Okay, Eric DeSormo with Peripher. We're a startup based in the SF Bay Area, and we're kind of at that point where our technology has been demonstrated all over the world. We have projects now on every continent, but it's almost impossible to find the way to do it here in the States. It's very difficult to get money. It's very difficult to scale up. So it's a forward osmosis technology, which you mentioned earlier, and you mentioned that's not at municipal scale. But we are doing municipal projects. We are doing potable reuse projects, and almost no one in the U.S.
Your major problem is getting money?
What's that?
Is it making money? Is that the problem?
I mean, yeah, everything is expensive in the beginning. Yeah. You have to get the cost down. So we got funding from the California Energy Commission to do 6 reuse projects in California, which will be able to demonstrate our data. And that's a new thing in California, which is really helping startups like us. So, but it would be great to have a clearinghouse where people could find about new technologies, because we're well known outside the U.S., but not necessarily in the U.S.
Okay. Well, over here, lady right there.
Yeah, I'm Madeline Glickfeld. I'm here both as a regional water board member and a...
which region?
Region 4, LA.
Region 4, thank you.
And also head of the UCLA Water Resources Group. And as a regulator, I can tell you that hundreds of different technologies are brought to the state board and the regional boards. And we don't have the capacity to tell the good from the bad or really understand their impacts. And we need to have that. There is really, especially right now, because companies are burgeoning up everywhere. I think it's really important that there be some kind of a very highly placed technical advisory committee for the state water board that can help them sort out what's real and what's not. And the other thing is that I think it's really important to educate the regulators on what's coming down the line. Our board is constantly now being presented with systems that are self-monitoring, have sensors. They're really uncomfortable with it. Our staff is uncomfortable with it. They know about grab samples. They know how the big issue for them is how often to require them. When you have something that's being monitored 24/7, why do that? So I think that's one of the things that we have to start talking about.
Well, I think there's 2 comments from that. The first one is the try to figure out a way that we could put a group together in the state that could be looking at these new technologies and then looking at them and informing people like the State Control Board what may be coming down the road that they need to be able to give regulations against or approve and whatever. Right. And then the last one was the issue of This technology, the staffs and stuff. Right. And the staffs of the, okay. And you all don't know what these things are you're looking at. You want more knowledge to understand them. Okay. Okay, go ahead. Mic's not on. Yeah.
Yeah, it should be.
I'm sorry. So Rhodes Trussell with Trussell Technologies. I think one of the most effective ways for these technologies to get to the point where they're scaled up and accepted by the regulators and by the government agencies that have to fund them is funding demonstration projects. So examples would be your project in Panoche for the drain, the project you mentioned you're funding with Eastern, the demonstration project in San Diego that has come up. There's also one that Padre Dam is doing. Demonstration projects like Orange County did, like Santa Clara is doing. These projects where somebody builds something full scale and operates it for a year or two and collects a lot of data have a huge impact on the degree to which a utility, degree to which the industry both the regulators and the industry can accept technology. And what we need are more forums, more funding for these kinds of things, and more forums where they can happen. And of course, a decision-making process that helps us decide which ones are blessed with this funding would be wonderful. But the decentralized process we have going on now, where people that are interested in these technologies hear all these things proposed to them and select one they'd like to get the Bureau to fund, and then the Bureau or some other agency, the state, participates in the funding is, I think, a good thing. There's just not enough money.
Well, the interesting thing on the one at Eastern is that Eastern wanted that checked by somebody other than just take GE's word for it, and they actually are paying the Bureau to be there as an impartial party. So the funding is an issue, but they're actually asking, paying us to be there. And we do the one with Padre also. Carl? Okay.
Yes, Carl Longley. I have to concur with Madeline's comments as a member of the Central Valley Regional Water Board. We need something like a certification agency. Am I off or on?
You're on.
A certification agency. So there's a label that, yes, this piece of equipment does meet what it says it does. And we don't have that, and it causes tremendous confusion among users of the equipment. What Rhodes is saying, I've been saying this for a long time in maybe a little different way, but we need directed research to solve problems that have been identified. We don't have that, and it's kind of a mishmash out there. Funding oftentimes goes for technologies that have been, where already a lot of research has been done. Where we're not seeing an advancement of the state of knowledge, and I think that the dollars could be better used.
Right. So our research programs tend to be ad hoc, right? And then,
exactly.
You mentioned certification. That's a different process. That's what NSF does. They certify equipment. And I think there's a bar lower than that. I call it validation. And we could use protocols to standardize validation for these technologies. Because right now, on the demonstration project Rhodes talks about, they come up with a test plan, a different test plan for every single one. There's nothing standardized. So and I think the state would benefit from something like that.
Okay, could take a couple more questions, but I want to take with people that have not had a chance to say anything, because if you've already had a chance to talk, we need to get other ideas, and then we can come back if we have time.
In the back.
We had one right here in the red shirt right there. Can we get him? Okay, give him where? There you go.
Hi, my name is Frank Schubert. I'm from the Tracy Renewable Energy, and I've been around the water business and technology industry in California for about 10 years. And I can say that it's extremely hard to bring new technology into California. And part of the reason, and I know it seems odd statement in this room, but there are people who do not want to find a solution, who make money on the fact that water is very expensive and rare. I think that's a bit of a problem, but not maybe as much. Anyway, we've been, my company has basically just sticks with commercial applications right now. We have tested this water on agricultural, our machinery's on agricultural water and half a dozen times now, and it works every time. But we stay away from that area. We're doing one, and I'm talking about the scale up here. We started with a gallon a minute through our machine. Now we're up to about 2,000 gallons a minute. We're putting in a plant that's going to do 1 million gallons a day for the city of Tracy, and we've disguised it as an ethanol plant because we didn't want to get shot down. That plant, we're going to break ground probably in August for that plant, and I think that's going to be a scale up that'll be workable for a lot of other places.
Okay, thank you. Right here.
Yeah, my name is Jim Souls. I'm a green builder, residential, and my sense is maybe 20-25% of the participants here are really interested in smaller and medium scale on-site. And I think we need 2 summits. Separate the municipal discussions from the on-site, because I think it's been very frustrating to try to find out more about on-site. NSF International was not even invited to this summit. I actually helped encourage them at least getting to be an observer when in fact you know that they have a certification process and they're certified three systems now for on-site equipment that could be used in residential construction in California.
So I think to come out of this is that the non-big site, the stuff that's more localized individual ones, we need to have somehow have a meeting on that. Okay, we're going to go back to that, and if we have time, number 3, there's always a lot of barriers to increasing water reuse and augmenting existing supplies. So has there anybody got some? Because I know some new ones have been coming up. New question, you can answer again. Okay. What? Okay, real quick.
Yeah. We're organizing an on-site water technology symposium for September 16th in Silicon Valley. So anybody who wants to be involved with that, please see me during the day.
Okay. Microphone's not working.
Right, let's try.
There you go.
Yeah. All right, it works. So, Baju Gaburi with Cambrian Innovation again, and Laura, thank you for the plug. Why aren't 400 other people buying it, right? The issue that I see, to be honest, the issue that I see is it's hard enough to set up an infrastructure change, right, to a wastewater treatment plant. The permitting process is painful, downright painful. It takes a long time. It goes into both the how do we scale up as well as the barriers to increase the wastewater or water reuse side of it. We're doing that. We can show it. We have modular containerized system. How do we cut the permitting process down to make it faster? Can one agency, when one county approves it, can we just copy paste that? Do I have to go through that pain every time, Right. So that's how.
So it's a great comment, and we're seeing improvements there. San Francisco's done a lot of work on this. Now they're working on a project to try to take that on a national scale. But people just don't have the information, the local public health officials that permit these, to give that. They don't have the information that will allow them to cut the permitting at this point.
Okay.
Okay. To his point about the permitting process, and I understand that very well with NSF International, I hear that all the time, that's just the longest time to get something done. And I was just talking with a customer that is NSF certified, and they were just approved in one county, and I think that's a fabulous idea, that if you are approved in one county, then those counties can share that process and maybe have that at a state level, that they get on a state list, and then all of the counties would follow the same process.
The only thing I'd add to that is that it sounds like a good idea, but remember, a lot of things about reuse plants, there are a lot of site-specific issues that are different from county to county, coastal, inland, and stuff like that. That has to always be considered. So that has to be in the process. Can we get gentleman back there?
Hi, I'm Zita Rohn. I'm with the California Council of Science and Technology. And just a general comment on
I don't have anything specific to barriers, but I would say that there seems to be two major paths to this problem. One is organizational, and you solve the problem with those people who actually have the water and distribute it, but you don't really deal with the people who use it at the local level. The other thing I kind of want to make a comment on is the marketing that goes on, at least in Southern California, that's targeted at the end user. And it seems to me that there's some sort of unthought of strategy here that is having negative effects on the whole issue of embracing new technology. And if you think about the marketing strategy, it's punitive. Right? We're talking about penalizing people. We're talking about restricting water use. There's no marketing that talks about doing more with less. And so I think the innovation that we're talking about here is limited to, or should not be limited to, technology and hardware, but should be innovative in the way we talk to people about the water use and why it is they need to partner with us to solve this problem. A lot of it's punitive. Thank you.
Okay. I will also add, in addition to the regulatory environment barriers, on the design side, as somebody who's worked on several of these projects in California, architects don't understand the technology, engineers don't understand the technology. You go to a plumbing engineer, they talk about sizing the pipe. I apologize to anyone who's a plumbing engineer in here. But a wastewater engineer understands this, and those are not the people on design teams. So when a client asks us, what about water reuse? First, the architect goes, does it smell? That's the yuck factor, I don't want it. Engineers don't know how to size it. And then you ask your subcontractors to throw a number at an Aquacel machine, and they throw in a number that's 4 times more just for the pipe than it should be. So it's perception versus reality. We're working on some professional education to reach out to that in the state, but that's one of the big barriers, is just designers don't know anything about this. They never learned it. Okay? We were never taught this.
Anybody else? Lady right here? And I'll get back to you. We got 5 more minutes and we have to pull our session together.
My question for discussion is regarding the capture of rainwater and the use of rainwater for technologies other than watering one's garden, specifically filtering it to potable standards. It doesn't take too much to take rainwater. It's fairly clean. You might want to remineralize it. So I'm wondering why rainwater hasn't been part of the discussion today.
Well, there are some ordinances in Southern California, particularly in LA and some other counties, and not everybody allows you to do it, but they do. And they also have places where they let you catch gray water, which nobody talked much about. And so that right now is probably more local because it has to have an ordinance by the local governments to make it happen. But it's a good way to get extra water. That's not more of a big thing. That's kind of a more smaller thing. Yes.
Just wanted to make one extra comment as you think about the testing and certification of technologies and so on. 2 water agencies I know of, one is Anglian Water in the UK, one is Ontario Water in Canada, actually make sections of their infrastructure available as a test rig, kind of like Fresno State does with, they got that pump test rig down there and all that kind of thing. There's a thought beyond that. As you do that, you're going to make it easier to innovate in California, notwithstanding all the permitting issues that we've just heard. You're going to generate economic activity. So the real payback for doing this, or the added payback for doing this, is you will probably add on in the long run to the state's GDP, because you will get more businesses that situate themselves in California, just as they have around Fresno State because of that test rig right now.
One of the things that I just wanted to add as one of the ones for number 3 real quick is that once Orange County did their plant, that became the standard for the state. And it's a great idea, except that it costs a lot of money to build it. The key thing you need to think about is that I've actually talked with someone from my research people in Denver as well as a consultant. There's 5 steps in that plan, and they're looking at trying to take 3 of the steps and do them in a way that they can combine them, and then they only have 3 steps. And that's going to be something they're going to try to do because it reduces the energy cost tremendously, but it gets the same treatment. If that works, then hopefully they'll be opening to new technologies because it will be considered a new way of doing things. And my frustration is that how long is it going to take? Because everybody's set right now to Orange County is the way to do it. And it's a great system, but it is expensive. One more, and then we're going to have to cut out and kind of sum everything up. So, okay, here, well, 2 more, and I'll get the one way in the back, too. Okay.
So Steve Green with Xylem. Mainly we're municipally focused with our treatment equipment. And interesting thing we experience is that often, depending on the funding agency involved in a bid, that the rules that are put forth in that situation, sometimes it actually penalizes innovation. So I think that it's important to look at what those rules are and what their purpose is. And we can always be competitive, but we don't like to be penalized for being an innovator. And oftentimes the lowest cost provider is not necessarily the best solution or the best innovation.
You probably feel like you're penalized, but that's just a process, right? And it's frustrating. And but how to streamline that is, I think, a very valid comment.
This is probably a question I should have asked earlier. Do you see, and this is for the group, the fact of the 80% reduction in greenhouse gas emissions to 2050 impacting permitting and the use of technologies that may be good for reducing water, but end up using more energy at the point of use? That's a question.
Very valid point. One more and that's it right there.
Hi, I'm Bill Eisenstein from the NSF Engineering Research Center on reinventing the nation's urban water infrastructure. And I wanted to, with respect to number 3, I just wanted to point out or remind everybody that one of the fundamental barriers here is that building new infrastructure takes a long time. Recycling plants and maybe even more significantly the redistribution infrastructure to distribute the recycled water takes a lot of time. And in the depths of a drought, everybody understands that this is necessary, and if we could do it today, we would. But if we do get a great El Nino this winter, what's going to happen to political and public attention to these issues? Are we going to be able to sustain it over the amount of time it would be necessary to, to really reinvent this infrastructure? And so the reason I bring this up in this audience is that I think for the utilities, for the private entities here, the businesses that are associated with these technologies, we need to keep up the messaging. Even if the drought breaks, we need to keep up the messaging that this stuff is important. And if this happens again in 10 years, we're actually going to be in a worse state than we are now because we've done a lot of the low-hanging fruit already.
But I do think the one comment that adds to that is, having been in the government 36 years, you get money usually when you don't need it, and people won't plan for things when you need it, like a drought. And I think that's an excellent statement, because no matter what we do to get out of this drought, all these ideas need to continue to be pursued so we're ready for the next one. Now, we appreciate everybody's comments, and I'm sorry we didn't get to everybody, but we're going to have someone give it an email address here. You can send anything you didn't get in this, and then they'll add it to the discussion and make sure it gets in. Can you give them the email address? Yeah, I'm going to put it up. Bill, okay. They're going to put it up on the screen for you. Hold on.
Okay, and they told me that lunch is going to be in the Klamath Room, which I believe is straight out the door, and that's going to start actually now. So thank you for your attendance, Bill.
Anything you want to send in, here's the email address, and that will get in the minutes of the meeting, so it'll get to the governor. Can you take it and put it in white? They won't do it. Okay. Okay.
Good job, guys. Hey, how you doing? It's good to see you.
Hi.
So we missed the phone call this morning, Jeff. I hope they handled it okay.
Oh, you missed it too?
Yeah, Karen was going to be on it. Yeah. They're on top of the situation. I think